Welcome back to our video notes over 3B4, atomic number, mass number. In our last video, we finished with example 3. So we will now pick up with example 4. Example 4 is asking us to write the hyphen notation for a neutral isotope. Got to know what hyphen notation is to do this. Remember, there's different ways to express isotopes of an element. Isotopes are just the different forms or different forms of atoms that a particular element can have. For instance, carbon has 3 isotopes, carbon 12, carbon 13, and carbon 14. Hyphen notation is asking us to express it where you write the element's name, hyphen mass number, or element symbol, hyphen mass number. Here it's symbol, hyphen mass number. Now when we use hyphen notation, they're assuming you have a periodic table of elements to look up the atomic number or the number of protons. So this would be like the hyphen notation for the 3 carbon isotopes. All an atom has to have be carbon is 6 protons. The number of neutrons doesn't matter. So carbon 12 has 6 neutrons, carbon 13 has 7, 6 and 7 is 13. Carbon 14 has 8 neutrons, 8 and 6 is 14. So those are the 3 isotopes of carbon. But we would need a periodic table of elements to look up the atomic number of carbon, which is 6. Now, if you look in carbon's box, there is no mass numbers. Why? Because every element on this periodic table can have different atoms making them up. The characteristic of the atom, though, is that it has to have the same number of protons. So, for instance, oxygen is any atom with 8 protons. Some oxygens only have 15 things in the nucleus. Some of them have 16. Other oxygens might have different things in the nucleus. So these numbers that you see here, the 12.01 for carbon, is the average mass of all the carbon atoms in a sample. Some of the carbon atoms, most of the carbon atoms in a sample would have a mass of 12. A few would have a mass of 13. A few would have a mass of 14. But by and large, almost all the carbons would have a mass very close to 12, or will have a mass of 12. So the average of all those masses is 1201. So this decimal number is not the mass number, it's the atomic mass, which is the average of the naturally occurring isotopes of that element. So in this question right here, they're asking for the hyphen notation for an element, and that for an atom, and that atom's neutral. Neutral means the number of protons equal the number of electrons. So this particular atom has 35 electrons. If it has 35 electrons and it's neutral, electrons are negative, there must be 35 positive protons to balance it out. So we already know by telling us it's neutral and by telling us that there's 35 electrons, we now know there's 35 protons. So we have to have a periodic table of elements to use hyphen notation. So we take a look. What atom here has 35 protons? It's bromine. Bromine has 35 protons. So we now know for our hyphen notation that we're dealing with bromine. So our hyphen notation would have to start off with bromine. We could either write bromine out or we can write Br out in a hyphen. But hyphen notation has the mass number after the hyphen. It does not have the atomic number. The atomic number is on the periodic table, so the hyphen notation doesn't need to tell us the atomic number. So how many protons and neutrons total would it have? Well, we know it has 35 protons. Here they told us it has 45 neutrons. So the mass number is protons plus neutrons. 35 and 45 is 80. This is bromine 80, or Br80 for the hyphen notation. Example 5. How many total electrons does calcium 2 plus have? Ca is calcium. We need to know that. How many total electrons does Ca2 plus have? Well, in order to do this, we would need a periodic table of elements. If we look on a periodic table of elements, we would find calcium right over here. You would need to look for the Ca, and we would need to look in the upper left-hand corner. Calcium has an atomic number of 20. Calcium has an atomic number of 20. Therefore, it starts with 20 protons, or always has 20 protons in the nucleus. But if it has 20 protons in the nucleus, then it starts with 20 electrons, because an atom, before it reacts, has equal numbers of protons and electrons. So calcium has 20 electrons. They're wanting to know calcium 2 plus. They're wanting to know how many electrons calcium 2 plus has. Remember, if it's a positive ion, it's lost. Lost has a positive sign at the end, which is really a T. It's lost 2 of its negatives. It has to have lost 2 negatives because it now has 2 more protons. 2 plus means there's 2 more protons than electrons. So if it starts with 20 electrons and it's 2 plus, it lost 2 of the electrons. It lost 2 negative things since it now has a positive charge. So if it starts with 20 electrons and it's lost 2 electrons, it would be left with 18 electrons. Looking at the periodic table of elements, if calcium loses 2 electrons, it would go to, if it lost 1, it would have 19. If it lost 2, it would have 18. All atoms are trying to get stable. The elements that are stable is this inert or noble gas family. The inert or noble gases do not react. Why don't they react chemically? Because they're already stable. So if calcium loses 2 electrons, it becomes stable like argon. Argon has 18 protons and 18 electrons. If calcium loses 2 of its electrons, it's like argon. That's the way it works. Earlier, we looked at charges of different elements up here, and we saw that if it's on this side, if it's close to this side, they will gain electrons. So how many electrons would oxygen have to gain in order to be stable? It starts with 8 protons, therefore it starts with 8 electrons. Neon is stable, so oxygen would have to gain 2 electrons or become O2 minus in a chemical reaction to get stable. Rubidium's number 37 right here. Rubidium starts with 37 electrons because it has 37 protons in the nucleus. What would it do to get stable? The noble gas that has the number closest to 37 is krypton. Krypton has 36. So what would rubidium want to do? It would want to become +1. +1 means it lost a negative electron. It would have 37 positives and only 36 minuses. It has one more positive than a minus, so rubidium wants to get 1 plus, lose its electron, and end up like krypton with 36. Tell how many, on number 6, tell how many electrons are gained or lost. Lost means it's positive. It's a cation. Gained has the N right in the middle. It's negative. Anion. N right in the middle. So if aluminum's 3 plus, plus means it lost 3 electrons. We come over to the periodic table. Here's aluminum. Why would aluminum want to become 3 plus or lose 3 electrons? Well, if it lost 1, it would have the same number of magnesium. If it lost 2, it would have the same number of sodium. If it lost 3, it would have the same number as neon, which is a stable, noble, or inert. Inert means it doesn't react. It doesn't react because it has the electrons it wants. So aluminum needs to lose 3 to be like neon. We already mentioned oxygen loves to be 2 minus. If it's minus, if it's negative, it gained electrons. Why would oxygen want to gain 2 negatives? When it's 2 negative, it means it gained 2 negative electrons. They just don't put the E in there. 2 minus means 2 E's have been gained. So O2 minus. Why would oxygen want to gain 2? Here's oxygen. If it gains 2, it would be like neon. Neon has 10. Neon's chemically stable. Makes sense that that's what it would want to do. What about K? K's potassium. You can write that it's plus by either writing a plus or by writing 1 plus. They mean the same thing. 1 plus means plus. Just like here, you could write 2 negative symbols instead of 2 minus. Here we could write positive, positive, positive. It's the same as 3 plus. It's positive. Positive. The positive symbols, that right there, the word lost has the positive symbol in it. Positive means it's lost electrons, it's formed a cation. How many electrons has potassium lost to be left positive? It's lost one electron. It now has one more proton than electron. When it's positive, it means there's one more positive than negative. It must have lost a negative. Why would potassium, it's right here, want to lose an electron? It starts with 11 electrons. If it loses one, it would have 10 like neon. Again, it would make it chemically stable. Nitride ion has 3 minus. I should have called this the oxide ion because when it's a negative, they put an "ide" on the end. When it's positive, they leave the ending the same. This is the aluminum ion. This is the oxide ion. This is the potassium ion. This is the nitride ion. "Ide" means it gained electrons. Gained, N, negative. This is negative. It's an anion. The nitride ion has 3 minus. It's gained 3 minuses. It's gained 3 electrons. Why would it do that? Here's nitrogen. If it gains electrons, it becomes nitride. Why would it gain 3? Well, it needs 3 to end up chemically stable like the inert gas or noble gas neon. The chloride ion is Cl. You can write it with a minus or you can write it with a 1 minus. The same thing here, 3 minus. I could write a minus, and a minus, but it's easier to write a 3 minus. When it's a minus, it's just easier to write it as a 1 minus. A single minus. Or you can write 1 minus, it means the same thing. When it's negative, there's one more negative thing. There's one more electron than proton. Why would the chloride ion want, or why would chlorine want to gain 1 and become like the chloride ion? Here's chlorine, atomic number 17. It starts with 17 protons and 17 electrons. If it gains an electron, if it steals an electron and forms an ionic bond off another atom and gains an electron, it would have 18. It would be stable, just like argon. Here's, again, barium 2+. We wouldn't call it baride. The ides go on the negative ones. So when you hear ide, you know it's become negative. When you don't hear ide, you know it's positive. The barium ion became 2+. Plus means it lost negative things. It now has more positives, protons, than negatives. So we need to look and see how many does barium start with, and why would it want to lose 2? If we go to the periodic table of elements, we find barium right down here. Why would barium want to lose 2? Well, it starts with this. It has 56 protons, which means it starts with 56 electrons. What's the noble gas that has electrons closest to barium's number? It's xenon, 54. So if barium loses 2, if it loses 1, it would have the same number of cesium. If it loses 2, it would have the same number of xenon, which would mean that it would be stable, because this is the noble gas column. They are all stable. If we notice something, we looked at these family right here, the Roman 1, or the group 1. They wanted to lose 1. This family right here, we saw that they wanted to gain 2. The elements here all need to lose 2. This family here needs to lose 1 to get like the noble gases. So if lithium lost 1, it would go from 3 down to 2 like helium. If rubidium lost 1, it would go from 37 down to 36 like krypton. Strontium starts with 38. It would need to lose 2 to become krypton. So this family needs to lose 2. Aluminum needed to lose 3 to become like neon. 13 minus 3 is 10. As we move through, we saw nitrogen and phosphorus. They would need to gain 3. Arsenic would need to gain 3. These guys like to be 3 minus. This family right here, group 16, likes to become 2 minus. We saw some of these in this family need 1 electron to become 1 minus. If iodine gets 1, 53 plus 1 would take it to 54. We're going to take a look in our next video what this looks like on a periodic table. What are the ions that these elements like to form? We'll pick that up in the next video.